standard position. All right, so this is a little bit, I don't know, makes sense to me because I've been doing it for a while, but when I say it out loud, it doesn't make a ton of sense. Okay, so we're going to do this on a coordinate plane, right? So in the standard position, you start at the positive x-axis. Everybody knows where that is? Right, coordinate plane. So positive x-axis is that side. You guys got me? Okay, and then okay, so you start here and then you rotate counterclockwise. That's a positive angle measure. Okay, so when I talk about a standard position, we're starting on the positive x-axis and we are going to rotate our terminal arm in a counterclockwise direction. Okay? All right, okay, so that's the starting point of it. All right, so we're going to look at it on the coordinate plane, like I said. You should already know your signpost in town, which you know. You know how to measure, do and measure of angle in degrees. We did that yesterday. Able to find sides and angles using the trig ratios. Got it. And being able to use Pythagorean theorem. Are you confident in these? Okay, cool. Because that's what I'm assuming you can do. Moving forward, our little review yesterday was it for me. I'm assuming you can do all that. So if you can't, not the end of the world, or you're not as comfortable with it, we just need to make sure you're practicing it and reviewing it. But I'm assuming you can do all of those things. All right, so here's my pretty picture. So like I said, we are going to put triangles inside of a circle. And this circle we call, in grade 12, we call it a unit circle because it has a radius measurement of 1 unit circle. That's the big. All right. So if we have a point on the unit circle, so let's say this is 2, 4. All right. We know that that means the base of our triangle is going to be how much? 2, because we're starting from the origin, and we know the origin is 0, 0. And we're going our x value, we're going 2 to the right. So we know the base would be 2. Right? Yes, we're good. And the height of the triangle, we're starting at 0 and we're going up to 4. So the height of our triangle would be 4. Now, how would I find the hypotenuse of this one? I use Pythagorean because I have no angles at this point. So I jump right to Pythagorean because this is a 90-degree angle here. Okay? So for funsies, let's just do that. So we've got 2 squared plus 4 squared equals c squared. So I have 4, 16 plus c squared. So c squared is 20. So c is going to be the root of 20. We just finished radicals. We're comfortable with radicals, right? We're like, oh my God, I survived. So this would be, the radius of this would be 2 root 5. That's a 5, by the way. So that's how I would deal with that. Everybody comfortable with it? So the 2, 4 tells me my base versus my height, and then I would use Pythagorean theorem to find my hypotenuse. Okay, initial arm. So going to this pretty picture, the initial side, if starting from standard position, will always start on the positive x-axis. Okay, so the initial arm is where your angle starts. What do you think the terminal arm is? Where you end, right? Where's your angle end? So if we're looking at this pretty picture up here, we know that our angle measurement would start at the blue and go to the red. So I'd be trying to solve for that angle in there. Does that make sense to everybody? And my angle started here and went counterclockwise. So it's in a counterclockwise motion. Okay, that's a positive angle. If it went down here, oh, this is exciting. Okay, so let's say it's down here. So in standard position, I should measure from my positive x-axis, and I should go in a counterclockwise direction. And that would be my angle. That whole thing would be my angle. Now, that's a lot. That's a lot of angle happening here. We know it's definitely greater than 270, right? You guys would agree with me? I have no idea where it is. Notice that the arrow to indicate my angle has an arrowhead on it because it indicates that we're measuring in a counterclockwise direction. Now, we could also do it in grade 12. We're going to get smarter. We're going to start doing negative angles. That's a way easier angle to measure for this little one. But right now in grade 11, we're going to stick with the positive. And you're like, why don't you teach us the negative? And I totally can. There's nothing wrong with that. But there's some rules that are going to help us along. So this here is our angle. In here, if we solved for this is called a reference angle. So it's like the thing that helps us find our real angle. So the orange would be our real angle. So we're always measuring in a counterclockwise direction. Oh, we're going to do this angle in standard position. I need to write this again. We wrote it up at the top. Yes, I need to write it again. So it fills in the box and your notes are perfect. Okay, all right. There's no shame in that. How do you feel about the abbreviation? I try to abbreviate wherever possible. Counterclockwise. You guys good with that? All right. So like I said here, the orange is my real theta. This is my angle. It's a really big angle. And we're going to be smarter than that. We're not going to measure negative angles like in grade 12. But what we are going to do, instead of figuring all this out, we're going to figure that out. Okay? There's a few rules to go with it. Everybody know what an acute angle is? Angle less than 90 degrees. So we're going to have the acute angle. I'm going to call it the real angle. I don't think that's appropriate. I'm not sure that's really mathy. Don't tell anyone except for when I post this video on YouTube and everybody hears it. It's the real angle. It's the larger angle. Obtuse angle, but it would be beyond obtuse because obtuse only goes to 180. Reflex is when it goes bigger than that. So it could be 180. It could be a reflex. So I don't want to call it obtuse because I think it can go bigger than that. So it's the real or the larger angle. So it's this little tiny angle that we find. So the acute, the little tiny cute one, that's going to help us find our real angle. Does that make sense to everybody? Yes? Kind of, sort of? Okay. And we're really good at dealing with 90-degree triangles. You did it in grade 10, you were successful. You did it yesterday, you were successful. You guys could do it in your sleep. Are you guys comfortable with that? Okay, all right, I'm going to hit pause.